Okay, can you see my screen? Can you hear my voice clearly?
Clear po.
Yes, sir.
Okay, so before we proceed with the design of the beams that we have picked, no, as far as the maximum moment force is concerned, I'd like to add uh, some more specifications on our a model, okay, to just to make sure that everything will be complete when we go to the design aspect of uh, the particular member we are going to design. Okay, but this is not uh, compulsory to include in the process of modeling, but it helps a lot dealing with the code compliance. Makakatulong ito sa pag-comply dun sa mga requirements ng code natin. Okay? Okay, so here is your model now. The first is I'd like to give you an additional specification on the reduction factor that we need to cover the inelastic response of the structure. Anong ibig sabihin nito? Pag nagkaroon na ng earthquake class, yung structure mo magkakaroon na ng inelastic behavior. No? So, ibig sabihin, yung bakal mo pwedeng mag-yield, yung concrete mo pwede na mag-crack. Tama? Okay, so because of that, we now have to anticipate a reduction on the member property. Okay, so if you still remember, we go to the general and then property here. So these sectional definitions of the member are actually uncracked section. Okay, so the properties derived from here, if you take the values of these prismatic rectangular sections, are based on the full uh, dimensions or sectional geometry of your member. And therefore, in actual, within the inelastic range, there are some inconsistency in applying this property. So we need to reduce this property, but we cannot change the section in terms of the definition of your property here. So STAD Select Series 6 actually included a way on how to address this problem. In the lower STAD, I don't think this is already uh, included, no, in the program, but here on the STAD Pro V8i, you simply need to go to specification and define a certain property reduction factor here to address the reduction in terms of percentages or in terms of factors less than 1. Okay? Okay, so What you will do now is first to select, okay, let's say the columns. I will select the columns, say um, beams or members parallel to the y-axis. So these are now the columns, no? And simply click beam here and click property reduction. I can now reduce my property based on a factor given here on this number box. Okay, so this input box here, we are referring to the cross-sectional area, the torsional constants, the moment of inertia, and the y, and the moment of inertia along z. Okay, so in the NSCP code, which I have not taken, no? Hindi ko siya nakuha, but I think I discussed this in my previous lecture on earthquake engineering. The NSCP, which is based on, I think, the ASCE also, because basically NSCP is an American code. We do not touch the first two criteria, no, on the cross-sectional area and constant, simply because we assume that there is no reduction in this. Wala tayong reduction. Bakit? Kasi in earthquake code, in seismic provisions of the NSCP code, we are defining a confinement such that even though your section is within the inelastic range or beyond the elastic range, the torsional resistance and the axial resistance is made to be 100% because of confinement. So hindi mo gagalawin yung dalawa ngayon, no? So ang gagalawin mo lang itong moment of inertia, because when your section cracks, then your moment of inertia will be reduced. And the code requirement for this is actually 70% of the original, or a reduction of 30% of the property. So you can place this 0.7 and also here 0.7. Okay, so that's the first thing you have to do for columns. Remember that. Then click assign. So you have it here. By the way, class, I already defined it. So let me delete. Okay, let me first delete my definition here. Okay. So for the beams, I need to select the beams parallel to X and the beams parallel to Y, or Z rather. So these are now the beams. And again, repeat my procedure on how to input the property reduction factor. But this time, your reduction factor for the moment of inertia is R, 0.35 on both direction. Okay? So kung yung column 70, yung beam 35% na lang ang natitira mo. So it's actually half of the beam reduction. So kung marami 70%, mas malaki yung doble yung laki nung reduction nung beams. So ano yung reason for that? Simply because beams are moment members. Okay, they are bending, they are critical in bending moments, and moment of inertia refers to the bending moment. Okay, kaya mas delikado, kaya mas malaki yung reduction niya. Okay, mas maliit actually yung factor, pero mas malaki yung nabawas. It's 65%, which is taken out from the original. So you simply assign it, and then you have here these two. Okay, so you can try doing now an analysis just to make sure that there is no problem on your input file, and look into the results. Okay, so this is the comment here, no? So ito is the interpretation of what I did. So did I change the value of my moment? Okay, unfortunately, we have not um, made a screenshot of what are the results. But just to give you the interpretation, if you will look into the diagram, okay, like this, I will tell you that there is no significant change in the moment. Eh bakit pa natin ginawa? Okay? Sir, wala naman palang magbabago, ba't pa natin ginawa? So the reason for that, pag ni-reduce mo to, lalaki yung drift natin. No? Ano yung drift? Pag nag-earthquake, lalaki yung galaw. Lalaki yung lateral sway. Yung side sway na tinatawag natin sa theory of structures. So pag lumaki yung side sway, we have to guard against it because the code limits us only a certain amount of static lateral movement for a structure to be acceptable. Imagine kung yung structure mo matibay nga pero nagsusway naman ng napakalaki. Kung ikaw yung may nakatira dun sa condominium, let's say nasa pinakataas ka na floor. So lagay mo bibilin mo yung unit na yon. Kung yung sway niya let's say is 1 meter, pag nag-earthquake, eh baka hindi ka nga mamatay sa collapse, mamatay ka sa sakit sa puso, no? Ma-atake ka, ma-stroke ka, ma-heart attack ka. So you have to not only to see to it that your building is strong, but also to see to it that your building is within the allowable serviceability requirement, which is the drift requirement. Okay? Kung may deflection control tayo, dapat may drift control din tayo. So, doon natin gagamitin ito. Later, pag gusto natin tignan, yung story drift natin or yung maximum drift natin at a certain story, which is more or less the last level of the floor. Okay? The building. So, yun yung gamit nito. Pangalawa, kaya natin nilagay ito is we also want to see the effect on the distribution of forces from one member to the other. Kasi pag lumiliit itong mga property na to class, nagkakaroon ng flexible behavior yung iyong structure compared kung walang reduction dahil rigid siya, no? So a rigid structure behaves differently from a flexible structure. But if you will look at the result on the moment, particularly on the moment forces, I will tell you without showing you the proof that there's no significant change. Okay? And you want to try it on your own, pwede nyo i-check yan. Okay, so that's it for the first. The second additional parameter I want is you may opt to do an envelope combinations or load envelopes definitions. Okay, so how do you do a load envelope? So you just go to the load tab here, and I already created a load envelope. Let me delete it. Okay. So what is this load envelope for? Okay, so this load envelope is for easy access to your selected load combinations. Okay, I'd like to remind you again that the load combinations here are only very basic load combinations. If you will look at the complete load combinations suggested by the code, you will have a lot of combinations for earthquake and wind in both directions. Okay, so in the new NSCP requirement, we are adding 30% of the effect of the orthogonal direction. So nagkakaroon pa ng 0.30 EZ ito, no? Ito naman nagkakaroon ng 0.30 EX. So I don't want to discuss to you that at this point, because I know if you will be involved in designing, you will have to uh, to study the complete procedure on how to take care of the load combinations. Okay, so you also have to consider a normal addition, okay, of your load effects in terms of the direction. Like if this is these are both positive, of course, but this can be a negative, so you can place a negative 1.0 EX there and a positive EZ here, 0.30 EZ, and vice versa, no? So in short, these load combinations here from 5 to 9 will actually be more or less doubled or tripled in terms of having the most critical load envelopes. That's why it's very useful to define and add load envelopes here. But what did I tell you in my initial discussion? The reason why I only choose this is because your structure is very symmetrical, and therefore this will more or less create the maximum effect uh, on the forces that will be induced on the beams. Kasi symmetrical naman yung ano natin eh. Kaya pwede mong anticipate na pag nag-minus ka dito, liliit yung effect niya, no? So plus plus lang tayo lahat. But for a non-symmetrical building, then I think you have to test a minus 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 here, and then a plus 0.30 of your orthogonal direction is a. Okay, I'm not we're not going to do it here because it will just create confusion on us on the interpretation. Okay, so how do you add it? You just select. Okay, normally you select all the x's in combination, one combination, and the other z on another combination. So I just add it here. Okay, my type must be a strength type. If my purpose is to check for serviceability, I will check serviceability requirement. If my purpose is on strength, I will check the strength requirement. Okay, so this is now add. Okay, so you will see it here, and then I'll select again another strength requirement for my envelope 2, which is the z direction, and then I just click add here. Okay, sorry, so just click add here. So there you are. So this is my load combination that I will be using later, and also member ranges. Okay, so if I'm going to look at the results of the analysis, okay, so these beams here are just have actually have very small, okay, have very small moment compared to the beams on the middle. Okay, so I will focus more on the beams on the middle. Let's say what if I make use of this, okay, beams here as my Okay, so my second floor beams 2022, 2028, 2034, and 2040 as my beam ranges for analysis. So I just go to the post processing, or maybe I must create first a view, a save. Okay, uh, okay, so I will save a view now. Say this is this second floor of beams, Z direction. Okay, so this is my view. And if I go to the post processing, so this is the post processing workspace. Okay, so this is my pool. And I select envelope 1 or envelopes 2 rather, because this is on the Z direction. So envelope 2. I can also check the range, no, on the view. Let's say I have this second floor beam direction as my range, as my filter, no, to capture all these ranges here. Or you can put a range number here in terms of the beam numbers if you want. Okay, but it's easier to have a view, save view, because you have only to select the name, no. Okay, so this is now apply. Okay, so you will see here that my moment diagram on the beam forces is just limited to 4 beams: 2028, 2034, 2040, okay, and 2022. Okay, so if I click the envelope, so here's my maximum moments. Okay, so these are the moments that I need. Okay, so for the 4 beams, okay, so these are the maximum moments. So what did I do now? I can now capture this and save it on another file, let's say the Excel, and start my design. Or I can directly design this using STAAD. No? But again, I don't want you to be very confident in using STAAD. What we are going to do in this next activity is to do a program to check the reinforcement that STAAD will be giving us when we design this beam. Okay? So I'll show you how to capture it later, but first we move on into the design. So what is now the design? So you go back to the modeling workspace, and go to your design tab. Okay, so this is concrete, and ACI 318-2011 is the latest code in American code we have here. Okay, and then select the parameters. So this is now my, and define it. Okay, so the parameters involved are those which are very worthwhile. The FC, or the FC prime, Fy main, Fy sec, the maximum main, and minimum sec. So these are the worthwhile parameters. There are a lot of parameters you can actually include, but these are the basic parameters, and these are the important parameters you need to be able to define before you proceed with the beam design routine. Okay, so I'll just click OK there, and then define the properties in the units place. Okay, so this is let's say grade concrete grade 3000 or grade 20. So I just place here 20,000, then assign. Then I get FY main is 276. Okay. Then FY secondary. So these are for the stirrups. I used grade 33 reinforcement. Or the maximum main reinforcement size, I use 20. And for the minimum main, I use 16. So these are the main bars, and the stirrups, I use 10. Okay. So everything will be placed here in that order. Unfortunately, meron na akong na-define dati, kaya na-doble siya. No? Okay, so let me just remove it. Okay, so okay, so this is now ready to be designed. So I just okay, I just click commands here, and then beam design or design beam assign. Okay, so I have it here. So my concrete design procedure is now complete. So I have to run the analysis again and save it first, and then that's done. No? Okay, so all you need to do is to double click and then concrete design. So the concrete design, as far as the main bars and the stirrups are concerned, are automatically placed here. Okay, so you can also see the design output here in this okay, so this is the beam 2022. It's the beam 2028. Okay, it's the beam 2034, and this is the beam 2040. Okay. Okay. So this is now my representation of all the beams on the second floor directed at the Z direction. So that's how I'm going to do my design. And as an additional part of your activity, we will be, as I've said a while ago, we will be doing a program maybe in MathCAD or Excel to check whether the reinforcement are more or less the same, okay, compared to what STAD has provided us here in this design summary here, okay? Itong summary niya dito. So, yun na i-check natin. So, how to do it? We go to processing and you simply capture the beam forces here based on the summary, the overall, or the envelope. So, you can use either the overall result, okay? You can use the summary as per the maximum, and you can use the envelope, which is the comparison of all the maximums here. If you want to represent each beam within the defined load combinations in the envelope itself. So ako, mas comfortable ako using the summary. Only the problem with the summary is that you are only getting the maximum MZ for the whole beam. So yung buong beam mo, isa lang yung representative niya, kundi yung maximum lang, no? So maganda din if you will be using an overall wherein all the beams here have their respective moments in terms of the load cases involved, okay, and just get the maximum here. Okay, so we can simply do a cut and paste. So what I do is I just cut and then I just paste it somewhere on my Excel worksheet. Okay, so here I will do a program that will give me all my AS. Lahat ito kukunin ko ng AS niya just to compare it with the result of the AS given by the individual beam design on STAAD. Okay? Okay, so I will, if I have time, I will show you how to capture it and place it on a MathCAD file so that you can do the programming on a MathCAD file. So that will be our next lesson, or the next activity after you have finished doing this, okay, this STAAD procedure that I made. For the meantime, I want you to go back to your lecture in RC on how to get the area AS for a singly reinforced and a doubly reinforced beam. So you must go back and recall how to get the steel requirement. Okay? So that when I discuss it next meeting, hindi kayo mawawala on how to do it. Of course, I will not be giving you the exact program, but I will just share to you the procedure and how there are a lot of ways to do it. I will show you how I did it, and you will do that either on Excel if you want or in MathCAD, and try to test or compare it with the STAAD result. So this is what we are going to do on the next activity. Okay, so that ends my presentation. So Juliana, you can now end the recording. So I'll just address your questions if you have any.